Today we're going to talk about troubleshooting and diagnosing non-PCM controlled charging systems. First, always start with a battery check. Batteries will eventually wear out, and even a good battery can become discharged for various reasons. When there are charging system problems, we might think the problem is the alternator, when it's something else. High resistance or unwanted resistance is one thing that leads to charging system problems. High resistance is usually one of these 5 issues: loose connections, corrosion in the cables or wiring, improperly sized wiring or cables, an improperly crimped connection, or failed electrical components. A visual inspection of cables and connections doesn't show what's going on inside of them. Voltage drop testing is the only sure way to determine if there's an adequate current delivery path. Watch our voltage drop video to learn how to check for voltage drop. Here's how to troubleshoot and diagnose electrical problems in non-PCM controlled charging systems. First, raise the hood and look at the belt tension and condition. Next, verify that all electrical connections, main cables, and plugs are clean and tight. Finally, make sure the alternator is mounted properly. Record a battery base voltage. With a voltmeter connected to the battery and the engine off, record a base voltage reading. Your battery should have a minimum of 12.4 volts. If the reading is less than 12.4 volts, charge and retest. Test the electrical pathway. Once the voltage reading is between 12.4 and 12.6 volts, start the engine and hold at about 1500 to 2000 RPM. Turn on all possible electrical loads: headlamps on high beam, defroster with blower on high speed, and any other accessories that require electrical power, except for wipers, which might scratch the windshield. Measure the voltage at the alternator. Place the black lead of the voltmeter on the case of the alternator and the red lead of the voltmeter on the alternator B+. If the reading is 12.6 volts or less, proceed to step 6. If the reading is 13.8 to 14.8 volts, then the alternator is working as designed. Measure the voltage at the battery. Place the black lead of the voltmeter on the negative battery terminal and the red lead of the voltmeter on the positive battery terminal. If the reading is 12.6 volts or less, proceed to step 6. If the reading is 13.8 to 14.8 volts, then the alternator is working as designed. If the difference between the battery and the alternator is greater than 0.5, you have a voltage drop. Refer to our voltage drop video. The primary emphasis in the next steps is to determine the root cause of no output. With the engine off, take a set of known good jumper cables and connect one black clamp to battery negative and the other black clamp to the alternator ground or case, and connect one red clamp to the alternator B+ terminal and the other red clamp to battery positive. Pay special attention not to ground the positive clamp once connected to battery positive, and make sure the negative clamp does not interfere with the belt system. With the engine running, repeat steps 4 and 5. Measure the voltage at the alternator and the battery. If the voltage reading is 13.8 to 14.8 volts, then the alternator is functioning normally. The issue is either in the positive or negative pathway. The jumper cables have bypassed the issue and the root cause still needs to be identified. If the voltage remains 12.6 or lower, proceed to step 10. With the voltmeter still connected to the battery and the engine running, remove the black clamp from the battery ground or case. If the voltage remains the same, then this part of the circuit is good. If the voltage drops back down, the negative ground circuit needs to be repaired or replaced. A voltage drop may be due to high resistance in the main negative cable that is caused by a loose connection, poor body ground, or corroded connections. With the voltmeter still connected to the battery and the engine running, remove the red clamp from the battery positive B+ terminal. If the voltage remains the same, then this part of the circuit is good. If the voltage drops back down, the circuit needs repaired or replaced. Pay special attention not to ground the positive clamp once removed from the alternator B+. A voltage drop may be due to high resistance in the main positive cable, caused by a loose connection, corroded connections, bus fuse, or fusible link. Begin diagnosis of the regulator control circuit by verifying that the regulator L terminal is receiving correct voltage. The L terminal is the input signal to the regulator and also acts as an output by grounding the lamp circuit, which is the charge indicator lamp bulb. With the ignition off, unplug the voltage regulator connector. Connect a test lamp. An LED test lamp will not work. Clamp the side to B+ and probe the regulator L terminal. By putting a 12-volt reference to the L with resistance, the test lamp is mimicking a lamplight circuit. Next, with key-on engine running and voltmeter still connected to the battery, take a reading. If the reading is 12.6 volts or less, the alternator needs to be replaced. If the reading is 13.8 to 14.8 volts after connecting the test light, the alternator is working as designed, and the root cause lies with the control circuit. Possible reasons for a control circuit failure include internal instrument cluster failure, battery charge indicator lamp bulb, instrument panel gauge fuse blown, corrosion at relay center or fuse block. Remember, it is a best practice to perform a voltage drop test before and after replacing the battery, starter, or alternator.